Padam!
Hello, welcome to Little Padam's Paper Steam. I'm Alita. This is Keffy. Hey Keffy, what are these materials for? Alita, have you finished your fingers? Of course I have. I finished it when I'm watching the video of you and Leslie. See these materials here? We're going to use them to replace the paper tendons and see if it will make our fingers more flexible. Oh, I also want to know which materials move the best. There's no time like present. Let's start. Today we've prepared 3 materials. We have this cardboard, nylon thread, and this rubber band. Let's take out our finger from the last section. What should we do then? Now we're going to try out different materials. The first thing we're gonna do is taking out the tendons. Hey! Then we're going to try out different materials. Where do you want to start? How about we start from the hardest one? The hardest material should be the yellow card. Gimme. Come to me. Let me put this cardboard in. Oh, I still have this tape from before. Ta-da! We have changed it into this card. Oh, what kind of difference will it make? Yeah, Adita, I see your finger is still using the paper tendons. Let's compare. Yeah. A little bumpy. Oh, wait. How come the hard one is so smooth? Why is this smooth? The harder material also provides better support. Indeed. Let's try out other materials together. Do you think the nylon will be even better? Let's give nylon a try. Gimme. I get the nylon. Are we starting? Okay, let me see. I really like this cardboard one. It was hard enough so it bangs back a bit when we release the finger. And it was just so smooth when it's moving. I wonder what nylon is like. Let me try. I think some of those thread is stuck between the joints. It's not as smooth as the cardboard one. Do you have longer tape? Yeah, I have. Wait. Now let's see. I don't think it looks too smooth. Oh, this part can't move at all. It's stuck. Yeah, I wonder why. That's because when it's pulled down, those threads of the nylon should have just stuck out from the joints. No. Now let's try out the last material. What's our last material again? Rubber band. And I actually thought nylon would be the better one. The structure is quite similar to your tendons. The result is not what I expected. Too thick? Perhaps it is. You can try to find some thinner nylon thread. Ours might be just too thick. That's your mission. Ouch, how can I even put that in? From the top? But it's so short. I think we should just combine them. Okay. I think it's too short. Are you worried that this is going to stuck like a nylon? Well, we won't know if we don't try it. And that's the stuck. Then we have to see if the tap can hold it. Better buy a few more rounds. What if it can't hold and it just bounces back and through and I have to do it again? Are we done? Oh, it's done. Come on, let's see the results. Oh, it's... That's smooth. So smooth, but this is so long. I'm about to let go. Keep it distant. Ouch! But when we were pulling it... Oh, that's interesting. Yeah, this feels natural. Indeed, and it has a bouncy feeling. It's just... It hits in the heart of my fingers. Everyone be careful when you're trying out the rubber band. Let's compare them. This is the original one.
and the rubber band. The rubber band one looks really flexible.
Yeah, the rubber one feels most akin to a real finger, but because it gets so long here when we're pulling, perhaps we need a tighter rubber band. How about trying out some materials yourself too? You can try what we tried today, and you can see if you can find a preference. To replace the tendon, personally, I quite like the rubber band. But if we are talking about stability, I think I like the top more.
Yeah, but the nylon one,
less passive.
yeah, it's not very good. But you can try to use thinner nylon. It might have a different effect. Again, I'll leave it to you.
After this, we're going to try something new.
Why our robot can only bend downward but not upward?
This is such a good question. I'll give you 5 seconds. See if you can answer it. I'll give you some content. Look at your robot hand. 1,
Robot hand?
and 5.
Maybe because of the joint?
That's partially right. Aside from the joints at the back of our finger are another set of tendons called extender tendon. On one side, it holds the shape of our fingers so they won't deform. On the other side, it's used for pulling up our finger after it's bended. Yeah, pull like that. After you bended the finger, it feels like there's a puppet string that pulls your fingers backward. So you can actually feel it. When you bend your fingers, you can feel the muscle at the back of your arm and hand just tighten, and that's how you move your fingers.
Oh, so that's why. But what is the function of the joint?
We use this joint to restrict the moving area of our fingers, so your fingers won't bend and free everywhere. You can only move in a few specific directions.
Oh, I understand now. What a complicated structure.
So, if we add another tendons at the back of our robot finger, we may able to pull it back after it's bended. But when it comes to adding another tendons, we will leave it to you. Try it out on your own. To help everyone understand the structure of our hands better, let me pull out my fingers back and explain it to you.
What are you going to do to your fingers? Chop it down?
What are you thinking? I was talking about the paper finger that I made with Leslie. We just played with
Excuse me, it feels like my heart is jumping out of my chest.
Wait, let's take our paper fingers out. Let's study this finger really carefully. It has 3 joints, but all 3 of them has the same angle. That's why it can look like a square. But when we compare to a real finger, our own finger, let's compare it again. Actually, the first joint of ours, look at this angle. Compared to the second and the third, they are all in different angles. Indeed, to make our finger even more realistic, each of the joints on this finger need to be in different angle.
But how can we know the differences?
Let's unfold it first.
Okay.
Yep, I have unfolded. Besides the tendons, did you notice there are actually 3 X here? The fact is, the angle of this X will affect the angle of the joints of our fingers. Let's look at this cross right over here. It looks like a right angle, which means 90 degrees. Now we're going to find out how the change of angle can affect the extent of bend of our finger.
Oh, so that's why. I really want to know the results.
Let's take out our diagram. We can notice there are 3 joints at different angles that is prepared for you. One is 90 degree, one is 60 degree, and one is 120 degree. The 90 degree one, very obviously, is just the angle of the finger we made. We have a sharp, narrow one, 60 degree, and acute angle, and a wider one, 120 degree, and a obtuse angle. We are going to try to fold this 3 angle out and compare the angles that they can bend. Now, action! Okay, now we have all 3 of these paper. Do you still remember how we fold our fingers? You can go back to our previous video if you forget. Let's see. First we have a 120 degree and we have a 90 degree here. Let's compare them and see the difference. Whoa, look at the 120 degree one. It can bend much lower than the 90 degree one. Now let's also take a look at the 60 degree one, the most narrow one. Clearly, it doesn't bend much. So now we have 3 different angles. The one able to bend the most is our 120 degree, and the less is the 60 degree. 90 degree is right in the middle. So if we want to mimic the real bending angle of our fingers, we can just change the paper of the cross that represents our joints. By changing these angles, we can stimulate the different bending angle of our joints. Don't forget to share with us the best materials you've discovered below at this comment section.
And don't forget to like, share, and subscribe to Padam's Paper.
See you next time. Bye
Bye bye.